Groundwater.
Isn't it stunning? What is it? Could it be a famous sculpture in the Museum of Fine Arts? But who is the artist?
Whoa, whoa, whoa. What you're looking at cannot be found in the Museum of Fine Arts. What you're looking at is an underground cave, and the artist or sculptor is the one and only water.
Wait, you mean there is water underground? How did it get there?
Yes, there is water underground. It's called
Groundwater.
It gets there by seeping down through tiny spaces in soil and rock called pores.
Just like surface water,
Groundwater.
flows downhill with the force of gravity. And just like surface water, it carves through rocks and deposits eroded materials elsewhere. Unlike surface water,
Groundwater.
can sometimes end up with higher amounts of acid in it. This is what makes it so good at carving caves. Let's see how this works, shall we?
Groundwater.
Is underground. That means it's carving through rock and dirt all day. As it does this, it dissolves minerals. These dissolved minerals can make the water acidic.
The more acidic the water is, the better it becomes at carving rock, especially a type of rock called limestone. Acid in the water causes a chemical reaction that cuts through that limestone like butter. Okay, not that easily, but more easily than non-acidic water.
A cave begins to be formed when
Groundwater.
flows into cracks in the limestone. From there, it continues to dissolve the rock. Over time, the crack widens into a larger opening called a crevice. Eventually, the water carves out a wide underground channel. The wider the channel, the more water it draws in from the nearest river or lake. This forms the cave's main stream.
Now here's the cool part. If the underground stream carves deeper into the ground or the ground rises, the water will continue to seep ever lower into crevices. Eventually, this will create a lower level to the cave. Over time, water will continue to trickle down through the crevices to this lower level. This constant trickling slowly sculpts the cave into a wonderland of rock formations, like the one we see here.
So water is the sculptor of this cave, but it doesn't work alone. It has a handy assistant. That assistant is acid from dissolved minerals.
Let's talk a bit more about
Groundwater.
Remember,
Groundwater.
makes up about 30% of Earth's fresh water, and it can be an important source of water for humans.
Sometimes groundwater can be accessed through a spring, which is an area where the water breaks through the surface of the ground. People also dig wells to access groundwater. Both springs and wells can be important sources of drinking water for many people.
When humans use
Groundwater.
as a resource, we can be assured that it is constantly being replenished by rain and nearby water sources.
However, it is important not to use groundwater supplies at a faster rate than they are naturally replenished.
This can cause the surface of the
Groundwater.
called the water table to drop and wells to run dry. Just like surface water
Groundwater.
is a resource that must be conserved.
I still remember the day the well at my parents' summer cottage ran dry. Come tea time, and my mother forced me to cry into her cup. Like that.
Glaciers.
Did you know that nearly 70% of Earth's freshwater is frozen in glaciers? That makes them pretty significant containers of water on the planet. But what exactly is a glacier?
A glacier is basically a huge hunk of moving ice. Glaciers form in places that are extremely cold, like polar regions, or places at high elevations like mountains.
glaciers form as a result of snow piling and piling up and never melting away. Over time, the layers of snow get so packed in under all the weight that they begin to form ice crystals. With all the weight on top of it, this ice begins, ever so slowly, to slide downward with gravity. This gigantic moving mass of ice and snow is a glacier.
Did you catch that? Glaciers move. Very, very slowly, they inch their way downward under the force of gravity. Let's get a closer look at glacial movement.
You would think that glaciers are so heavy that they wouldn't be able to move, right? But the opposite is true. The glacier's enormous weight is actually what causes it to move.
You see, The weight of the glacier causes ice on the bottom layer to melt and refreeze. This creates a layer of slush that allows the great ice beast to slide more easily.
Meanwhile, ice in the interior of the glacier keeps bending and changing shape under all of the weight. We call this deforming.
This continuous changing of shape allows the grains of ice to keep sliding past each other, creating a river of ice.
You're a river of ice! Oh!
As they flow, these rivers of ice scrape away features of the landscape, smoothing it out. They also carve out new landforms. And of course, they pick up lots of rocks and stuff and drop them off elsewhere. And we're not just talking puny little pebbles. Glaciers can pick up and move boulders the size of buildings.
Check it out. Here's a sample image of a mountain before any glacial action occurred. Here's the same mountain after some glaciers slid down it over thousands or even millions of years. As you can see, glaciers do some serious carving to the earth, turning smooth mountainsides into jagged peaks and valleys.
Remember, just like surface water and groundwater, glaciers are important forces of erosion and deposition on Earth.